We have this image of a heart beating here. Really, the heart pumps about 8,000 to 12,000 liters of blood each day. That's the same 5 to 6 liters circulating over and over all day long, 24/7, when you look at it from that perspective.
The question you should ask yourself is this: can the small muscle of the heart manage pumping all of that blood alone? The answer is no. Nothing works by itself, and therefore the heart has helpers. These are every vessel that's interconnected to it and through it. It's at the level of the smallest vessels that the real action is taking place. Blood and its components, which include arterioles, capillaries, and venules. You have initial lymphatic vessels and collecting ducts, as well as interstitial spaces. That's the region in between cells and vessels. As I said before, we're basically a hydraulic system. It's at this vascular level that oxygen and nutrients are transferred to our cells. Waste products simply are removed. It's also at this interface where blood flow is controlled and regulated, feeding back localized information to the nervous system and ultimately back to the heart and vessels. This is just an image looking at all the components that are found within the vessel itself. We always focus on the vasculature, but what are these vessels for? They contain white blood cells, plasma, red blood cells, and this makes up blood. Blood and plasma which moves through these vessels. This is the highway to health, delivering nutrients to target tissues. When you look at this area where the circle is, that's where the business takes place. Here's a clear visual example of the micro or small vessel versus macro or large vessels in the human heart.
In the image to the left, you can see that these are vessels greater than 200 microns. When one looks at a CT scan, imaging, or angiogram of the heart, this is where blockages can be observed. But when we look at the microvessels on the right side, which are less than 200 microns, this is where the problem develops but is rarely ascertained or seen until it's already too late.
Until someone manifests a heart attack or myocardial infarction, for example. So it's really these microvessels that play a crucial and vital role in maintaining both structure and function within the entire body. In fact, the microcirculatory system makes up the largest part of the circulation system. Almost 75% of the vessels within your body are microcirculatory vessels. That means 3/4 of your circulatory system is comprised of these small vessels. Some of these are smaller than even the diameter of a strand of hair. When looking at this simple depiction of microcirculation, we can identify the vessels by both their size and function. Oxygenated blood travels in through the arteries. Oxygen is delivered to the capillary network via these arteries and arterioles, then gets smaller and smaller into the capillary beds. Then once it drops off oxygen and nutrients, waste products are picked up and then deoxygenated blood is returned to the heart and the lungs via the venules and the veins. It's this transport phenomenon of material exchange between blood and tissues, as well as the first steps of cellular and humoral immune reactions. These are where it's focused in this area of the circulatory system.